All right, next set of examples. We're going to use our double angle formulas and combine that with some of the right triangle trig that we did in the first semester. So let the sine of an angle be 3/5, and the angle is in quadrant 2. So what would the exact value of the sine of 2 times the angle be? So the sine of 2a is going to be 2 times the sine of a times the cosine of a. Well, we only have the sine of a right now, so we need to find out what the cosine of a is. Remember, the sine of any angle is the y value over the r value, and the cosine of the angle is the x value over the r value. And that's one of the ways that we can find that since sine is 3, or y, over 5r, we can now start setting up that x squared plus 3 squared equals 5 squared. We're also in quadrant 2, so that means that our x value is actually going to be negative, because in quadrant 1, x and y are both positive. In quadrant 2, x is negative, but y is positive. Quadrant 3, both are negative. In quadrant 4, x is positive, but y is negative. Anyway, we're going to keep this as our negative value of x squared plus 9 equals 25, or the negative value of x squared equals 16. So the opposite of what we need is 4, which means what we actually need is negative 4. So that means our cosine is negative 4 over 5. So we can use that value here, and we'll use the sine value here. So we've got 2 times 3/5 times negative 4/5. 2 times 3 is 6, times 4 is, times negative 4 is negative 24 over 25. And that is the exact value of our angle. Since we've, actually no. So now, actually, since we've got both the sine and the cosine, we can find the cosine of 2a pretty easily, pretty quickly. The cosine of 2 times our angle is going to be the cosine squared of our angle minus the sine squared of our angle, which is going for us to be negative 4/5 squared minus 3/5 squared. Negative 4 squared is positive 16 over 25 minus 9 over 25 is going to get us 7 over 25 is our precise exact value of the cosine of whatever 2 times our angle is. To get the exact value of the tangent, we're going to need to find the tangent of the angle itself, because our formula says that the tangent of 2 times an angle is going to be 2 times the tangent of the angle divided by 1 minus the tangent of the angle, or the tangent squared of the angle. So if we go back to our x, y, and r ideas, remember that tangent is y over x, and since we already know that y is 3 and x is negative 4, then the tangent is negative 3/4. So we're really looking at 2 times negative 3/4 divided by 1 minus negative 3/4 squared. Now again, big fraction division like that looks a little bit weird, so let's turn it into some linear division to maybe help us out. We'll also simplify along the way. So 2 times negative 3 over 4, 2 and 4 can cancel down, so we'll have negative 3/2 divided by negative 3/4 squared is going to be positive 9 over 16, but we're still subtracting, so 1 minus 9/16. 1 we can make into 16 over 16. 16 minus 9 is 7. So we're really looking at negative 3 over 2 divided by 7 over 16, which we can now keep, change, and flip to make negative 3 over 2 times 16 over 7. 2 and 16 both divide by 2, so we get negative 24 over 7 is the exact value of the measure of the tangent of 2a. And again, a little bit of review to go back to some of the things that we need to remember from semester 1. What is the degree measure of angle A? We can take a sine inverse or a cosine inverse to find that, but remember we are in quadrant 2. So quadrant 2, our x needs to be negative and y needs to be positive. Quadrant 2, if the cosine is what we use, we'll get the exact value, but if we base our answer on what they gave us in the sine, we're actually going to have to take the second angle, because the sine inverse can give us the angle in the first quadrant, but 1 minus the principal value gives us this angle in the second quadrant that we'll actually need. So if we know that the sine of our angle is 3/5 and we're in degree mode, then the sine inverse of the sine of our angle is going to be the sine inverse of 3/5. Double check, make sure we're in degree mode. Looks like we are. So we'll take the sine inverse of 3/5 and get, it's about 36.87 if we round to 3 decimal places, 870. But remember, that's actually not the entire possibility of the answer. 36 degrees is not in quadrant 1. We also took a sine inverse, so we need to get that plus or minus 360 degrees any number of times we need to. We don't really need to right now, but it's still part of the full solution. The other one is 180 degrees minus our principal value, plus or minus 360 degrees any number of times we need. So again, we know that we're not going to need this 36.87. We're not going to need either of the plus or minus 360s for our final answer. Actually, we might need the plus or minus 360s, because all we know is that angle A is in quadrant 2. We don't actually know whether it's been rotated multiple times or not, so we will keep the plus or minus 360s for our final answer. So if we check 180 minus 38.87, remember to use your stored values in the calculator. 180 minus our previous answer, that is second and the negative button. Our precise value is this is not precise. This is already a rounded decimal. It's just rounded farther than we're going to use. But our 3 decimal point answer is 143.13. Plus or minus 360 degrees n. And again, because we're in quadrant 2, the one that's 1 minus our principal value, we know the measure of angle A has to be some variation of this 143.13. It could be positive or it could be positive or negative, depending on how we rotated and how many times we rotated. And that was your introduction to 3.4.